ParparVM started 4.21 times slower than warmed Java 25. After one optimization series, its 10 benchmark geomean reached parity. This is how an ahead-of-time client VM closed that gap. The harness alternated warmed HotSpot and ParparVM runs on the same M2, then required bit-identical output. Lower is better. String building finished at 0.67. Recursion remained 1.6. The geomean is 1. ParparVM's first advantage is structural. It compiles a closed world. No dynamic class loading, limited reflection, dead methods disappear, and single-target virtual calls become direct. The AOT compiler knows the whole application before it runs. The old generated C pushed a GC-visible frame for every Java call. Tagged stack slots forced values through memory, so C-lang could not keep them in registers. Frameless methods use plain C locals instead, and the optimizer finally sees ordinary C. Array bounds checks were not expensive by themselves. The failure helper returned into the loop, leaving a reachable call on every cycle. Making the throw path leave the method, let's see lang hoist array metadata. Quicksort fell below HotSpot while keeping every check. Allocation had a different problem. Every new object called malloc zeroed memory and searched for a tracking slot. The BiBOP heap groups one size class per page. Allocation becomes a pointer bump, while pages still come from the operating system. The collector never stops the world and never moves an object. The app keeps rendering while a background thread marks and sweeps. That choice preserves native pointers and a 2.4 megabyte idle floor. Peak allocation churn fell below Java 25. Auto-boxing was the final big lever. On 64-bit targets, integer values fit inside tagged pointers. The low bit distinguishes them from real objects, so boxing allocates nothing and the collector ignores them. The trade-off is identity, so locking on wrappers is rejected at build time. The result is not that an IoT VM always beats a JIT. HotSpot still wins recursion and tight arithmetic. The useful result is narrower. Client-sized memory, direct native access, and warm JVM throughput for 17 kilobytes of extra binary. The full benchmark, code, and methodology are linked below. Which optimization should we unpack next? Frameless calls, the allocator, or tagged integers?